All right, let's dive right in. We're going to talk about what is, no exaggeration, the biggest architectural shift in React's entire history. Seriously, this isn't just some new API or a minor update. We're talking about a fundamental change that takes React from being, just a client-side library to a full-on, full-stack architecture.
So, let me ask you a question. What if your React app could ship with almost zero JavaScript? I know, it sounds kind of crazy, right? Almost impossible. But here's the thing. This isn't just some thought experiment. It's the core promise of React's new server-first paradigm. And honestly, it's about to change everything we thought we knew about building with React.
Okay, so here's how we're going to break this down. We'll kick things off with the performance problem that led us here. Then we'll get into the Great Divide, this big new concept. We'll look at client versus server components, cover the new rules and patterns you got to know, check out the awesome performance benefits, and finally wrap it all up with the new mental model you'll need to adopt. All right, so first up, React's performance problem. Look, to really get why this new architecture is such a game changer, we first have to understand the problem it's trying to solve. The bottleneck that pretty much forced this whole evolution. So let's take a quick trip down memory lane. React's journey started with single-page apps, or SPAs. The idea was simple. The entire app renders right in your browser. And that was awesome for creating these really rich, app-like experiences. But the downside? Super slow initial load times and SEO headaches. So to fix that, along came server-side rendering, SSR. Now the server sends the initial HTML, which is way faster for that first paint. But you still had to ship this massive JavaScript bundle down to the client to hydrate the page and make everything interactive. And that's where we hit a wall, a performance wall. The JavaScript bundle itself became the #1 bottleneck, slowing everything down. So, how do you smash through that performance wall? The answer is this really cool concept called the Great Divide and something called the network boundary. This right here is the key idea. It's what unlocks all the performance gains we've been looking for. Okay, the network boundary. Picture a line in the sand. On one side, you've got the server. On the other, the client, the user's browser. This boundary is what separates the code that runs on the server from the code that has to be shipped to the client. And here's the magic part. Anything that stays on the server side of that line, it never gets sent to the browser, which means it adds exactly 0 kilobytes to your JavaScript bundle. Nothing. Zilch. So how do you tell a component, hey, you need to cross that line and go to the browser? It's incredibly simple. You just add this one little string at the very top of your file. Use client. That's it. Think of it like a passport. It's your explicit, deliberate signal to the framework saying, okay, this component absolutely needs to run in the browser. And that simple directive is what creates the two main characters in this new story, client components and server components. They're basically the two sides of the coin in this new React world, each living on its own side of that network boundary we just talked about. Now, this next part is maybe the most critical mental shift you'll have to make. Ready? Server components are now the default. Let that sink in. They run only on the server, have 0 impact on your bundle size, and they're absolutely perfect for things like fetching data. Client components, they're now the specialists. They're the ones you deliberately opt into only when you need that browser-side interactivity like state or click handlers. So what kind of things force you to add that use client directive? Well, it's pretty much everything you've come to associate with interactive in the browser React. We're talking about using hooks like useState for state or event handlers like onClick. Or maybe you need to access browser-only APIs like window or local storage. And of course, lifecycle logic with useEffect. If your component does any of these things, then yeah, it's got to be a client component. Let's just quickly look at the capabilities here. If you need state with useState or lifecycle events with useEffect, you have no choice. You have to use a client component. But check out where server components just completely dominate. They are the absolute best place for data fetching, they have 0 impact on your bundle, and this is a big one, you can safely use secrets like API keys directly in them because they never leave the server. That's something you could never do securely on the client. Okay, so we have these two types of components living in totally different environments, right? One's on the server, one's on the client. So naturally, there have to be some new rules for how they talk to each other. Let's look at the patterns that make this whole thing work together. All right, here is the golden rule, the #1 thing you absolutely have to remember. Any props you pass from a server component down to a client component must be serializable.
What's that mean? Well, it means you can't pass down functions, event handlers, or other complex stuff that can't be turned into a string. Think simple data, strings, numbers, objects, arrays, stuff that can be easily sent over the network.
So that leads to a great question. What if you need an interactive wrapper, like a pop-up modal, but you want the content inside it to be static and server rendered? This is where a super powerful pattern comes in, often called children as props. It works like this. Step 1, you build your interactive shell, the modal itself, as a client component. It has the state, the close button, all that stuff. Step 2, you take your heavy, data-rich content, say, a big article, and you keep that as a server component. And you just pass it as the children prop to your modal. The result? It's just brilliant. You get this tiny, lightweight interactive wrapper, but the huge chunk of static content inside it was rendered on the server and added 0 to your client bundle. It's the best of both worlds.
Okay, so we've learned all these new rules, these new patterns. Why are we doing all this? It all comes back to one thing, the performance payoff. This is the whole reason for this massive architectural shift.
And believe me, the difference this makes it's just night and day. If you look at a traditional single-page app, you often end up with this enormous JavaScript bundle. But with this new server-first model, because the vast majority of your components now contribute literally 0 bytes to that bundle, the final package you send to the browser is just drastically smaller. It's not even a close comparison. And what does a smaller bundle actually mean for the person using your site? It means a huge improvement in key performance metrics, like first, content will paint. In plain English, that's how fast something actually shows up on the screen. We're talking about the difference between a user staring at a blank white page, getting frustrated, and your site just snapping into view almost instantly. It creates a so much better, so much faster experience, right from the very first second. So, to sum up the key wins here, server components cost you nothing on the client. That leads directly to faster page loads and a much quicker time to interactive. And hydration is no longer this giant, expensive process for the whole page. Instead, it becomes a super efficient, targeted operation that only happens on the little interactive islands in your UI that actually need it. So all this new tech, all these patterns, it all leads to what is honestly the biggest change of all, the new mental model. This isn't just about learning a few new functions. It's about fundamentally shifting how you think about and approach building a React app from the ground up. So what does this new server-first thinking look like in practice? It's simple, really. You default to server components for everything. You start there. Then you become really surgical with that use client directive. You only add it when you absolutely have to, and you push it as far down the component tree as possible, keeping your client components small and isolated. And maybe most importantly, you move your data fetching out of the client and onto the server, where it's faster and more secure. You know, the whole philosophy can really be boiled down to this one idea. Embrace a server-first mindset and start thinking of client components as a deliberate, surgical tool you only pull out to add interactivity. Honestly, if you only take one thing away from all this, make it that.
And that kind of leaves us with one last question to chew on, looking towards the future. With things like the new React compiler on the horizon, frameworks are getting smarter and smarter. So, will we get to a point where we don't even have to make this decision anymore? Where the framework just looks at our code and automatically figures out the best place for it to run? It's a pretty exciting future to think about, that's for sure.